This is my experiment on charge tapes. The purpose of the experiment is to understand SX charge on matter and how that charged matter interacts with its surroundings. Some general physics concepts in this lab include electric field, electric force, gravitational force, conservation of charge, conductors and insulators, and charge interactions. Some observations that I noticed during this lab was that U-tape to a neutral object, like a book or a table or my hand, create an attractive force. And then U-tape to another piece of U-tape creates the repulsive force. And then U-tape to a negatively charged pen, which is charged by rubbing into my hair, creates a strong attractive force. So this shows that U-tape should be a positive charge. Some assumptions I made during the course of this lab was that each U-tape has equal charges. The tape should be treated as a point charge with equal charge distribution, and that air resistance is negligible. So here are some pictures of my experiment. The first picture represents my hand to a piece of U-tape. The second picture represents a piece of U-tape to another piece of U-tape. And the third picture shows me holding a pen to another piece of U-tape. Some fundamental questions for this lab was, what's the length of one of the pieces of tape? About 8 inches or 0.2 meters. Clear tape is about 1 gram per meter. And what's the mass of one of your pieces of tape? And that's about 0.2 grams, or I convert it to kilograms to keep in SI units. And then what was the distance between those two tapes and one began to float above the other? I said that was about 0.8 inches or 0.02 meters. And what was the magnitude of the gravitational force in the floating piece of tape? I used Fg equals mg, and I got 0.00196 n, and that would normally be in the negative y direction. And then for finding the magnitude of electric force in the tape, I substituted the Newton's third law, which says that every action is equal opposite reaction, that the electric force is equal to the negative gravitational force. So magnitude of Fe would also be equal to 0.00196 as well. In order to better model and understand how this experiment would work, I created a code that models the U-tape against another piece of U-tape. And so for this code, I started my constants, like the electric constant, charge of a proton, scale factors and distance factor for my arrow, gravitational acceleration, and then stuff for the tape like the mass, the length, and distance between the two tapes. And for my objects, I used 2 spheres to represent 2-point charges. For my initial values, I had r for distance vector, the magnitude of r, the normal vector of r, calculation for the electric field, and a calculation for the charge on the tape. Then I created a function just to make sure that everything should come out the same. And then for my e-tape, I used that function to calculate that value. And then for force, I made a vector for the gravitational force, and I took the magnitude of that for the electric force. Then I created arrows from those two values. So some calculations with excess electrons and the ratio of electrons and atoms. For excess electrons, I divided the tape charge by the charge of 1 electron. And then for the ratio of excess electrons to atoms, I divided the excess electrons by the number of surface atoms. And I found surface atoms by taking the cross-sectional area of tape and dividing that by the cross-sectional area of the atom. So some final conclusions that I reached with this lab was that the experiment showed the impacts of excess charge on surroundings by examining the electric field and electric forces on the tape. The tape has a positive charge, and interactions with neutral objects on the tape can gradually weaken that charge and force them not handled properly, which is why it's very important to keep holding the tape on its side instead of in the middle. If the charges were swapped, electrons had a positive charge and protons had a negative charge. The interactions would stay the same pretty much, but the objects with a more positive or negative charge would change. And then my computational model helped to represent the forces on the tape in the experiment and the charge in the tape. And lastly, the ratio of electrons to surface atoms show that a very small fraction of atoms lose or gain an electron, which, as you can see in my last calculation, was about 1,700 atoms would lose or gain an electron.